All right, let's take a look at how we solve quadratics. So there's three main strategies that I want to go over. The first one is the zero product property. So that one uses the fact that when there's a product that equals zero, either A and or B need to equal zero. So if we can get a quadratic in factored form where it's something times something else that equals zero, then either the first something, the first factor, has to equal zero, or the second something has to equal zero. And then we can solve these two mini equations to get the solutions to the quadratic. So what we can do then is take any quadratic, make sure we set it equal to zero, so bring all the terms to the left-hand side, in this case subtracting the 28, and then we can get to work factoring the quadratic. So in this quadratic we can factor out the 2. What's remaining is two numbers that multiply to negative 14, add to negative 5, so that's negative 7 and 2. We could cancel 2 from both sides. That's 2 times this. We can divide both sides by 2 to cancel it out. And then what's remaining are those two factors. Using the zero product property, setting them both equal to 0, we can get the solutions to the original quadratic. So 3 is the same thing, except the only it's already equal to 0. The only thing is the factoring is a little bit more sophisticated, so I'm using the split the middle term and then factor by grouping. So we think of two numbers that multiply to negative 6 and add to the middle number negative 5. That's negative 6 and 1. So we're going to split this middle term. Negative 5x is negative 6x plus 1, right? Negative 6x plus 1x is negative 5x. So we haven't changed the expression. We've just split the middle term. We group the first two and the last two. GCF of the first two terms is 3x. GCF of the second two terms is 1. Notice that's what is remaining is the same. That's our common group. That's one of our factors. And then the 3x plus 1 is our second factor. Now that we have it set up as a product equaling 0, we can use the zero product property that lets us set both of those equal to 0 and get our solution. So to solve a quadratic by factoring is the most common form that you'll see. You just have to make sure it's set equal to 0 first, factor correctly, and then solve. But not every quadratic can be factored. And so when there's only one quantity that is squared, or one x squared, not an x term, what we're going to do is isolate that squared term. And when we take the square root of both sides, don't forget the plus or minus. So for example, here's a basic one. Notice there's no x term, right? It's just the x squared and then the constants. What we're going to do is instead of setting the equation equal to 0, we're going to bring all the constants to one side. So in this case, add 4. And then we're going to isolate the squared. So I'm going to divide both sides by 9. X squared equals 4/3. Take the square root of both sides. Don't forget the plus or minus. Simplify as much as you can. So the square root of 4/3, we can give both the numerator and the denominator their own radical. The square root of 4 is 2. 2 over root 3. Now you could leave this as 2 over root 3, or you can rationalize by multiplying by root 3 over 3, and that's where we get the 2 root 3 over 3. Of course, don't forget that plus or minus in your solution. If it's a quadratic, there should be 2 solutions. So that's the square root method for this one. Here, all that differs is the quantity that's being squared has 2 terms. It's not just x squared, it's x plus 3 squared. So we're going to isolate this whole quantity. So we'll divide both sides by 3. We'll take the square root to undo the square. Remember the square root of 5, we're going to put plus or minus, and then we'll subtract 3. So negative 3 plus or minus root 5. This one just has a couple more steps. We have to, again, get all of the constants on this side and isolate the squared term. So first we're going to have to subtract the 14 and get negative 16 on the right, then divide both sides by 4. That's how we get the negative 4 here. Once we have the squared term isolated, that means all by itself, now we take the square root. Remember, don't do it preemptively. Make sure you subtract the 14 first, and that's where we got the negative 16. Then we divide both sides by 4. And that's where we get that negative 4. So make sure you take the steps to isolate the squared before you take the square root. Now in this case, remember, we can't take the square root of a negative in real numbers. So this is where we're going to use our imaginary numbers. The square root of negative is I. So we're going to plus or minus 2i. And then we'll subtract the 3 to, again, isolate x. So that's how we're going to use the square root method to solve a quadratic. And the last one, and this one's really nice because the first two, although they're really useful strategies, we can only use the zero product property if the quadratic is factorable. We can only use the square root method if it has just a one squared term and not a single x. But the quadratic we can use with any quadratic equation, right? As long as it's in this form, ax squared plus bx plus c equals 0, we can use this quadratic formula. And really the biggest thing is organization in this case. So number 7, it's already in standard form. A is 1, B is -4, C is -3. I like to put these placeholders in as blanks and then plug in B, A, and C, and so on. And then we just have to make sure that we're simplifying the radicals. So when you plug this into your calculator with parentheses, we get 28. So the square root of 28, 28 is 4 times 7, 4 is a perfect square, so the 2's come out, the 7 stays under the radical. And now what we're going to do is find the GCF of these three values of 4, 2, and 2. So the GCF of those three are 2. So we're going to factor out a 2 up here and get 2 and 1 for those. Factor out a 2 and get 1. The 2's cancel, and this is what we're left with. So that's our solution. Notice again, we have 2 solutions for the quadratic equation. Number 8 just has one extra step, one preliminary step, I should say, where the original equation is not equal to 0. So all we have to do is first slide the 5 over by subtracting it from both sides. And now that it's in standard form, we have A, B, and C, and we can plug it into the correct spots. Again, please make sure when you're typing this into your calculator, you're putting parentheses around the -2 squared. Otherwise, you'll get a negative here, and this needs to be positive. We end up getting the square root of 64, which is 8. So here, in this case, since it's not a radical, we actually can continue and evaluate. So we're going to take the two scenarios, 2 plus 8 over 6, and then the 2 minus 8 over 6, and get our 2 solutions that way. 2 plus 8 is 10. 10 divided by 6 is 5/3. 2 minus 8 is -6. -6 divided by 6 is -1. Awesome. If I went too quickly or you didn't get it all down, feel free to rewind, pause, do whatever you need to. Make sure you understand each of these examples, and then your homework is to work on, or the rest of the time in class, work on those practice problems. All right, guys, have a great day.